Hello everyone, good day. Welcome to my video lesson. I am Crystal Jane B. Macahito, your grade 9 mathematics teacher. Our lesson today is about quadratic inequalities. At the end of the lesson, the students are expected to describe quadratic inequalities using a variety of examples, graph quadratic inequalities using a variety of examples, and appreciate the application of quadratic inequalities in real-life situation. Now, what is quadratic inequalities? Quadratic inequalities is an equality that contains a polynomial of degree 2 and can be written in any of the following forms. Ax squared plus bx plus c is greater than 0. Ax squared plus bx plus c is less than 0. Ex squared plus bx plus c is greater than or equal to 0. Ax squared plus bx plus c is less than or equal to 0, where a, b, and c are real numbers and a is not equal to 0. Example of quadratic inequality, we have 2x squared plus 12x is greater than 1. 6t squared plus 2t is less than 0. 2x squared plus 11x is greater than or equal to 21. A squared plus 22j is less than or equal to 2. Remember that a mathematical sentence is considered not a quadratic inequality if it is written in as a quadratic equation. How to graph quadratic inequality? To graph a quadratic inequality, we're going to start by graphing the parabola. And fill in the region either above or below it, depending on the inequality. You can graph quadratic inequalities in two variables using the same techniques you use to graph linear inequalities in two variables. Step 1. Determine whether the boundary should be solid or dashed. Graph the quadratic function. Step 2. Test a point inside the parabola. Substitute the ordered pair of your choice, x, y, into the original inequality to see if this ordered pair is a solution. If the resulting inequality is true, shade inside the parabola. If the resulting inequality is false, shade outside your parabola. If the inequality symbol is less than or equal to or greater than or equal to, then the region includes the parabola, so it should be graphed with a solid line. Example: graph y is less than or equal to x squared plus 12x plus 32. The related equation is y is equal to x squared plus 12x plus 32. First, we notice that a, the coefficient of the x squared term, is equal to 1. Since a is positive, the parabola points upward. The right side can be factored in as y is equal to quantity x plus a times quantity x plus 4. So, the parabola has x-intercept at -8 and -4. The vertex must lie midway between these, so the x-coordinate of the vertex is -6. Plugging in this x value, we get y is equal to x squared plus 12x plus 32. Y is equal to -6 squared plus 12 times -6 plus 32. Y is equal to 36 minus 72 plus 32. Y is equal to negative 4. So the vertex is at negative 6, negative 4. Now, we have enough information to graph the parabola. Remember, to graph it, we will be using a solid line since the inequality is less than or equal to. And now, the question is, should you shade the region inside or outside the parabola? The best way to tell is to plug in a sample point. 0, 0 is usually the easiest example point to choose. Then, let's substitute 0, 0 to the original equation. Y is less than or equal to x squared plus 12x plus 32. So, we will substitute 0 to x and 0 to y from the equation y is less than or equal to x squared plus 12x plus 32. We have 0 is less than or equal to 0 squared plus 12 times 0 plus 32. 0 is less than 0 plus 0 plus 32. To obtain 0 is less than or equal to 32, which is correct. Therefore, 0, 0 is a solution. So, we will shade the region which include the point 0, 0. Otherwise, if the inequality symbol is less than or greater than, the parabola should be drawn with a dotted line to indicate that the region does not include its boundary. Another example, we have graph y is greater than x squared minus 8x plus 16. The related equation is y is equal to x squared minus 8x plus 16. First, we notice that a, the coefficient of the x squared term, is equal to 1. Since a is positive, the parabola points upward. The right side can be factored in as y is equal to quantity of x minus 4 times quantity of x minus 4. So, the parabola has x-intercept at 4 and 4. The vertex must lie midway between these, so the x-coordinate of the vertex is 4. Plugging this x value, we get y is equal to x squared minus 8x plus 16. Y is equal to 4 squared minus 8 times 4 plus 16. Y is equal to 16 minus 32 plus 16. And we get y is equal to 0. So, the vertex is at 4, 0. Now, we have enough information to graph the parabola. Remember to graph it with a dotted line since the inequality symbol is greater than. So, should we shade the region inside or outside the parabola? The best way to tell is to plug in a sample point. 0, 0 is usually the easiest example point to choose. Then, let's substitute 0, 0 to the original equation y is greater than x squared minus 8x plus 16. So, we will substitute 0 to x and 0 to y, and we obtain 0 is greater than 0 squared minus 8 times 0 plus 16. 0 is greater than 0 plus 0 plus 16. We obtain 0 is greater than 16, which is wrong. Therefore, 0, 0 is not a solution. So, we will going to shade the region which does not include the point 0, 0. Now, let's have another example of graphing. Graph y is greater than negative x squared plus 4x minus 3. Since the a here is negative, then our parabola opens downward, and it is a dotted line because of the symbol greater than. The vertex of y is greater than negative x squared plus 4x minus 3 is 2, 1. To solve the axis of symmetry, we're going to use the formula x is equal to negative b over 2a. So, x is equal to negative 4 over 2 times negative 1 is equal to 2. Then, to get the value of y, we just do a substitution. Substitute the x, which is 2, in the equation y is greater than negative x squared plus 4x minus 3. So, y is equal to negative 1 times 2 squared plus 4 times 2 minus 3 is equal to 1. So, the vertex is 2, 1. And to test if the solution is correct, we use the test point 0, 0. And we will substitute 0 to x and 0 to y in the equation y is greater than negative x squared plus 4x minus 3. We have 0 is greater than 0 squared plus 4 times 0 minus 3. And we obtain 0 is greater than negative 3, which is correct. Therefore, 0, 0 is a solution. So, 0, 0 must be shaded. Shade outside the parabola. And take note that if our symbol is greater than or less than, then we have a dashed line to tell us that the numbers that make up the line are not included in the solution. However, if we have a greater than or equal to and a less than or equal to symbol, then the numbers that make up the line are included. And so we draw a solid line. Remember that if we have a negative coefficient of x squared, you can move everything to the other side to make it positive, but be careful of the inequality sign. Now, to check your understanding, in a one-whole sheet of paper, answer the following mathematical sentence and determine whether each mathematical sentence is a quadratic inequality or not. For your next activity, you are going to identify which of the following are not quadratic inequality and use the given mathematical sentence below to answer the questions that follow. Number 1. Which of the given mathematical sentence are quadratic inequalities? Number 2. Which of the given mathematical sentence is not a quadratic inequality and why? Or number 3. How can you determine quadratic inequality? In Test B, using a graphing paper, graph the following quadratic inequality: y is greater than or equal to 2x squared minus 3x plus 1 and y is less than x squared plus 3x plus 2. And when you are done graphing, explain the importance of quadratic inequality in real-life situation. And for your assignment, in a long bond paper, formulate word problem involving real-life situation that deals with quadratic inequalities. And then answer your problem, identify the equation, and make a table of values, and then graph it. And that's all. Thank you for watching.